Okay, so we're now looking at how to differentiate logs. Now this isn't quite as easy as differentiation with exponentials, but the premise is this. If you've got y equals natural log of x, when you differentiate that, dy by dx equals 1 over x. And just as the same as exponentials, it's not as simple as that, but this is the key link that you've got to remember. This is one that's by far the most popular. And the way it differs slightly is if you've got y equals log of, say, 3x squared plus 4x minus 1. Let's say you've got the log of all of this. When you differentiate it, dy by dx, on the bottom you're going to have 3x squared plus 4x minus 1. And on the top, we differentiate what we've got on the bottom, let's plonk it on the top. So if we differentiate 3x squared, we get 6x. If we differentiate plus 4x, we get plus 4. The 1 just disappears. So we end up with 6x plus 4 over 3x squared plus 4x minus 1. Just one more quick example. If you've got y equals log of 6x, when you differentiate that, in exactly the same way, the 6x remains on the bottom. Differentiate 6x and it goes to 6 on the top. But you can simplify this one down. So if you simplify this one down, cancel out the 6's, and so you end up with 1 over x. So if you ever have a function which is log of something x, that always goes back to this one here, which is 1 over x. But just on the safe side, I'd always write, so if we're differentiating a log of 6x, I'd always write the 6x on the bottom, differentiate it, write that on the top, and then simplify it out. So let's have a look at different examples. So the first one is y equals 5 log x. Now we can write 5 log x as 5 times by log x, but this isn't the product rule. The reason being is that here we've got a function, but this is just a number. It's a bit like if we had y equals 3x squared. We don't use a product rule for that one because it's 3, it's just multiplying. So we can actually write it as 3 times by x squared, differentiate the x squared to get 2x to the power of 1, and then still times it by 3 to get 6x to the power of 1. In exactly the same way, over here, we ignore the 5 and we just differentiate the log x. So dy by dx equals 5 times by, if we differentiate log x, just like we saw on the previous screen right here, we've got 1 over x, which simplifies down to 5 over x. Okay, the next one. So let's get rid of this. So question B, and again, remember with all these videos you can pause them at any time just to finish off taking notes and then restart the video. So y equals log of 6x minus 1. So dy by dx, that goes on the bottom, so 6x minus 1 goes on the bottom. Differentiate it, and that just goes to 6 on the top. But of course we can't simplify this down because 6 doesn't go into everything here. You can't simplify, you can't cancel down the 6 from here and here. You could if we had a 6 as a third bit, but we don't. So we can't simplify that down, so it just stays as 6 over 6x minus 1. Now, the next question. We've got y equals x cubed log x. Now again, we've got two functions here. We've got x cubed and we've got natural log of x. So what we do is we differentiate, or we set this as u and this is v. So we've got u equals x cubed and we've got v equals log x. So if we differentiate u, we get 3x squared. If we differentiate v, we get 1 over x. And once we've done that, again, it's a product rule, so it's u dv plus v du. So u dv will be x cubed times by 1 over x. We'll do all cancelling in a second. And then v du is 3x squared times log x. And then by doing the, so that is dy by dx once we've differentiated. So if we then simplify the first bit here, we get x squared, then the second bit stays as it is, so plus 3x squared log x. And again, what we then do is we simplify it by factorising out the x squared, and we get x squared bracket 1 plus 3 log x. And then we can simplify that. So if we need to, we can set that equal to 0 by setting the first part equal to 0, setting the second part equal to 0 if the question asks for a turning point. But again, we'll have a look at how to apply all these things in a later session. But this is pretty much the nuts and bolts of differentiation when we have a look at logs. So if we have a look at the final two examples, we've got log 5x over x. Now again, we can see that these questions don't vary that much. We've got a function on the top, which we're going to call u. So we've got u equals log 5x. We've got a function on the bottom, which is just x. So we're going to say that v equals x. And when you've got a function on the top and the bottom, we use the quotient rule. Before we do that, we've got to find out what du equals. We've got to find out what dv equals. If v equals x, dv will equal 1. If u equals log 5x, then du equals 5x on the bottom, differentiate it and put it on the top, 5, which then simplifies down to 1 over x. And again, there's no shame in writing out that step, even if you know that it's going to go to 1 over x. It's always worth being safer than sorrier, I guess. So now, we've got the quotient rule, so we use v squared. No, we don't. Only joking. V du minus u dv all over v squared. So v du, we end up with 5x over 5x minus u dv, so that's u dv, that's minus log 5x times by 1, which just goes, and that's all over v squared, which is over x squared. You then tidy that up to end up with dy by dx equaling 1 minus log 5x over x squared. Now, there's nothing you can do to simplify that, so that just stays as it is. Now, the final one, we've got 2x plus ex log x. Now, just be careful with this one. First of all, it's not, the whole thing isn't a product rule, because we've got 2x plus e to the log x. So that's the first thing to state. Here we've got something plus something, so that doesn't make it a product rule. What makes it a product rule is this second part here. We've got e to the x multiplied by log x. The other thing to be careful of, and it's an easy mistake to make, is if you've got e to the x times log x, even though e and log are inverse functions, that is not e to the log x. They don't cancel out here. You've got two separate functions, but it's not, they don't cancel each other out. That would only be if it was log e to the x or e log x, but it's e to the x times log x. So just be really careful with that. And if needs be, rewind that a little bit of the video just so it's really, really clear. You can't cancel it out because you've got two functions, but they're not a function of a function. Okay, so soldiering on, we've got y equals 2x plus e to the x log x. So dy by dx equals, we differentiate the 2x to get 2, plus, and then we're going to differentiate e to the x log x. Now what I'm going to do is I'm going to leave this bit here, and that's where I'm going to write my answer. But I'm going to use the rest of the space to actually work this out. So I've now got to differentiate e to the x log x. So I'm going to take the first bit and call that u. So u equals e to the x. I'm going to call the second part v. So v equals log x. Now, whenever we do the product rule or the quotient rule, we work out what du and dv are. So du equals e to the x, nice and easy. dv equals 1 over x. So we've got u dv. So u times dv equals e to the x over x plus v du, which is e to the x log x. And of course, it wouldn't matter if you wrote down log x e to the x. For some reason, I always put e to the x first, I think because it's first alphabetically. But you're not going to get penalised if you wrote log x e to the x instead. So then, if you differentiate this here, e to the x log x, you get this thing here. So we're going to substitute that back in. So we've got, so this thing differentiates to e to the x over x plus e to the x log x. And we could leave it like that. I don't think we're going to get penalised. Because what we could have done here, and perhaps should have done, is factorise out the e to the x. There's no reason why we can't do it in the final answer. So 2 plus, then factorise out the e to the x. E to the x bracket 1 over x plus log x. And that, ladies and gentlemen, is how you do differentiation when using logs. And again, we're using the quotient rule, the product rule, and the chain rule. Didn't use the chain rule so much there. But what I'd like you to do now is have a go at exercise 8E, and then have a go at question 1. There's only one question there. It's question 1A to 1L. So enjoy that, and we're racing through differentiation.